maybe, hopefully. There we go. All right. So for today, we're finding volume still, but this time it's going to be for a pyramid or a cone. And yeah, so for pyramids and cones, and actually it's a very similar volume formula. And so as we very similar to what we had yesterday. So this shouldn't take us too much longer or be too different than what we did yesterday. So with that, go ahead and grab your notes and let's get started. Make that bigger, make sure it's zoomed okay. Okay. So this is like 11.5, still volume. But this time we're talking about pyramids and cones. Okay, so pyramids and cones tend to be shapes that people are a little bit more familiar with. You know, we know about ice cream cones and pyramids in Egypt and things like that. So we're more familiar with these shapes, at least than kind of our typical like prisms yesterday that we might not have been as familiar with. But just in case, a cone, and the distinction between a cone versus like a pyramid is that a cone has a circular base. So if we're looking for a cone example, there we go. And then a pyramid can have one of two other kinds of base shapes. So pyramids can have either a square or rectangle base. And this is going to be fun to attempt to draw. Yeah, not too terrible. All right, so there's one possible pyramid. I guess this should have been a dashed line as well. Or it could have a triangular base. Okay, so these would be pyramids. This would specifically be a rectangular pyramid. This would be a triangular pyramid. And then this would be considered a cone. Okay. And so then the base on these pyramids or cones determines a little bit of our volume formula, or it does just as much as yesterday's did, I guess. So let's take a look at that volume formula that we're going to get. So volume is going to be equal to, we're still going to have capital B times H, but it's not just going to be capital B times H, because that would be like the volume of a cylinder or something like that with the same height. It's going to be area of the base times the height divided by 3. So if you can kind of liken this to, you know, how when we were working with parallelograms and triangles, and the area of a parallelogram was base times height, and the area of a triangle was base times height divided by 2. It's similar to that idea. The volume of a prism or a cylinder is area of the base times the height. Volume for a pyramid or a cone is area of the base times the height divided by 3. So yeah, usually if we were like in person and stuff, we would do a little activity where we can pour like a volume of a cone. We would fill it and then dump 3 of them into a cylinder to show that 3 of those is what it would take to fill up the cylinder with the same height. But I don't have that supplies with me, and we're not in person where it could be a little bit more fun of a demonstration. But anyways, We get the idea. Here's the volume formula. So the only difference between what we're doing today and what we did yesterday is that we're going to divide by 3 when we get our answer. So this is still area of the base. This is still the height. And when we're looking at these different pyramids and cones and whatnot, the height is going to be the distance between the point and the base. Or the vertex and the base. So in this case, that might be our height. And so it's that vertical distance, perpendicular distance. So if they gave you like the length of this side or something like that, that would not be the height. The height has to be perpendicular to the base. And then the base for a cone would be a circle. For a rectangular prism, or for a rectangular pyramid, it would be a rectangle. For a triangular pyramid, it would be a triangle. So again, this is going to be very similar to what we did yesterday. So let's go ahead and do an example. We're going to have lots more wonderful drawings of cones and whatnot. First example, let's go with a cone this time. And we are told that this dimension here is 8 inches, and this dimension here is 3 inches. Okay. So again, this is a cone. So it has a circle base. And we know volume, area of the base, times the height divided by 3. So then the base is going to be pi r squared, just like it was yesterday for cylinders. So looking at this picture, what's r going to be? 3. Yeah, we know the radius here is 3. So that would be pi times 3 squared, which would be 9 pi, which is something we can type into the calculator to get an approximate answer for. About 28.274. If you want to round to the nearest hundredth, you should keep 3 decimal places at least, so that when you round, you don't end up with too much rounding error at the end. All right, and then what would the height be for this thing? 8. Yeah, that's the distance between the point and the base. So then finding our volume here, 28.274 times 8 divided by 3, tossing that into the calculator. We get 75.3973 repeating. So what we would then want to do is round to the nearest hundredth. But if I do that here, notice that the 7 would round the 9 up. So really we end up with 75.4. And this would be cubic inches. Just like yesterday, our units will still be cubed. Okay. So looking at that one, are there any questions? Any numbers we're not sure where they came from? Steps we're not sure how they happened or what's going on? Okay. So again, this shouldn't be too much different than yesterday. The only difference is we're dividing by 3. So this is more practice with the same kind of thing that we did yesterday. Okay. So let's do another. Let's do a pyramid this time. And we get to draw another fun pyramid. We're going to do one with a rectangle base. All right. This dimension is 8 centimeters. This dimension is 6 centimeters, and this dimension is 6 centimeters. Okay. So this time, this pyramid has a rectangle base or a square base. So that means the area of the base is going to be base times height or length times width. Whichever way you want to think of it is fine. Okay. So to find the area of the base, we just have to do 6 times 6. Since that's our base right here, these are our 2 base dimensions. So we get 36 there. And then the overall height of this thing is 8. So to do our volume, area of the base times the height divided by 3, we're just going 36 times 8 divided by 3. And that we can type into a calculator. So we should get 96 cubic inches. Okay. Another way that you could think of this one is, since it's a rectangular prism or a rectangular pyramid, sorry, you could go length times width times height divided by 3. That would yield the same result here. Because if you remember when we did rectangular prisms, we just did length times width times height, or that was another way you could do it. And so you could take that same thing and then just divide by 3 this time if you want to. That would also be another way you could think of this problem. Any questions about the second example? Okay, so the last different scenario that we'll see is one with a triangle base. So it shouldn't be all too different except for the difference in the base formula. Okay, so let's see here. And this is going to be a right triangle base, just for fun. And that dimension there is going to be 17 feet. This one will be 8 feet, and this one will be 14 feet. Take a moment, draw that. If you can, I know drawing in 3 dimensions can be kind of difficult. So do your best. If it doesn't look amazing, that's okay. The ones that come up on your IXL will look a lot better than yours or mine. Okay. So this time we have a triangle base. So that means that our base formula is going to be base times height divided by 2. Okay. So what are our base and height going to be for that bottom triangle? What do we think? What would the base and height dimensions be? So remember, base and height have to be perpendicular to each other. But from this perspective, it doesn't really matter which one is the base and which one is the height when we're looking at this right triangle here. Because the special thing about right triangles is that one of the sides is going to be the base and the other side is going to be the height. So just that 8 and that 14 will be our base and height. And it doesn't matter which one is which, because from one perspective, this could be the base and this could be the height. From another perspective, this could be the base and this could be the height. And since we're multiplying, we can multiply in any order that we want to. So for our area of the base, we're just going to go 14 times 8 divided by 2. And we get 56 for the area of the base. And then what's the height of the pyramid overall? Yeah, 17. Exactly. So the height of the pyramid overall is 17. And then all we have to do, volume is base times height, so 56 times 17 divided by 3. So 56 times 17 over 3 goes into the calculator, and we get about 317.33. It's really 3 repeating, so if you wanted to, 3 repeating is also known as the fraction 1/3. So you could do it that way and have it be 317 and 1/3. And this would be cubic feet. Most of the time you'll just be asked for the decimal though. Okay, so those are kind of the 3 different types of problems that you are going to see. You'll have a cone, you'll have the rectangular base pyramid, and you'll have the triangular base pyramid. Any questions about any of those 3 or any that we want to go back to? Okay. Then I'm going to have you guys try 1 or 2, and then we'll get on our way here. This one has a diameter of 10 inches. And then we'll say that this is 2 centimeters, 4 centimeters, and 3 centimeters there. Okay, so give those two a try. I'll kind of give hints as we go. When you think you've got them both, put "got it" in the chat. On the first one, if you figured out that the base area is pi r squared, which would mean pi times 5 squared, you're on the right track. Remember that on this one, you're given the diameter, so you need to make it into a radius by dividing by 2. All right, Jade's got it. Awesome. Caleb's got it. Lauren, nice. All right, on the first one, we should have gotten that the height is 20 inches. So then 78.540 times 20 divided by 3. And on the second one, we should have noticed that the base is a triangle, so it's going to be base times height divided by 2, with our base and height of 4 and 2. So 4 times 2 divided by 2, which is just 4. Then the overall height was 3. So the volume formula we set up, 4 times 3 divided by 3, which again is just 4. So if you got 4 for the second one, you are correct. And then for the first one, what did we get for that first one? People who found an answer, what did you get? Anybody willing to share their answer here? All right. No one's interested. We should get 523.6 cubic inches. So if that's what you got, you did it correctly. If you got something else on either of these two, look and see if you can find the spot where things went wrong. Did we forget that this is a diameter maybe and put 10 as the radius by mistake? Over here, did we put down an incorrect height or base anywhere? Did we forget to divide by 2? Anything like that might have contributed. But if you got it right, awesome. So real quick, before we're done or move on to homework or anything like that, let's take a quick poll. On a scale of 1 to 5, how do we feel about finding the volume of a pyramid or a cone? 1 being super confused, would love some more examples. 5 being, this is really easy for me. What are we feeling right now? I would love for everybody to vote. Show me that you're there and awake. If for some reason you cannot vote in the poll because the app isn't letting you or something like that, type in the chat instead. All right, I know there's more than 11 of us out there. Yeah, 30 more seconds to vote or to type in the chat. All right, looking like we're mostly 3s and 4s here. So here's what I'll do. Just like yesterday, I'm going to post the homework. We'll take a look at a problem or two from that. And then if you would like more examples, you can stick around and get more examples. And if you would like to go and work independently, you can go work independently. All right, so today's is one more IXL. It is T6 this time. So yesterday was T5, today is T6. So let's jump over to Classroom. Might have to refresh the page, but here it is, volume of pyramids and cones. All right. Oh, this is almost like our, exactly like our example number 2, except the height is different. So on this one, for the rectangular pyramid, we talked a little bit about how you could just go length times width times height divided by 3 if you want to. And that's probably what I would do here. Just go 6 times 6 times 9 divided by 3. And we would get 108 cubic millimeters. All right, this is going to be another case where for this IXL section, you get to use 3.14 instead of the pi button. So make sure you pay attention to that and use the number 3.14 instead of pi. So for this one, to find the area of that base, if the radius is 4, we would go 3.14 times 4 squared. And then you would multiply by the height of 5. And then divide by 3 since it's a cone. And we would get, let's see, we're rounding to the nearest hundredth. So that would be 83.73. Okay. That's pretty much what all of these are going to be like. You might get some triangular pyramids in there. But other than that, we shouldn't see anything too much more difficult than these. So at this point, if you would like to go and work independently, you are welcome to do so. If you would like to stick around and get more examples, you can also do that. Yeah, if you're leaving, have a wonderful day. See you tomorrow. Remember, tomorrow we're meeting at 10 o'clock instead for first period and working independently until then.